So here we're looking at a log from RC Slater, um, uh, and I'm just going to touch on a couple questions you asked before we get to your video and your traces. Um, One of the things you asked about is your dropouts in your log and whether you should be at 1 to 2 logging. If you're able to log at loop time 1000 and 1 to 1 without dropouts, then keep doing it. Um, I looked at your logs and it doesn't look like you have excessive dropouts. I run loop time 1000 and 1 to 2 logging, so I should have plenty of overhead, and I still have dropouts every now and then. At one point I tried 1 to 3 logging and I still had a dropout every now and then. So it seems like there is something in the system that causes there to be occasional dropouts, even if you have plenty of overhead in terms of the throughput of the logger. So it looks to me like you're doing fine at 1 to 1 logging and 1000 loop time. I'd say keep it up. Uh, as far as this question about your filtering, this question depends on how much noise your copter has. If you have a very clean I mean, Boris, when he was developing the soft filters, before he developed gyro cut hertz and p-term cut hertz, and there was only the d-term filter, he was flying gyro LPF equals 256 with just a d-term filter, and flying and said it was the best thing he'd ever done. And I tried it, and no way. So my copter is not clean enough to get away with that, and his copter is. So we can take a look at your gyro traces, um, and we can see how noisy your copter is. We'll zoom all the way out. And looking at your gyro traces, it's not the cleanest one I've ever seen, but there is a little bit of noise in there. Um, so could you get away? Looks like you have a little bit more noise in this one. I'm not sure. Maybe your filter settings changed. Um, let's look at your last one. Yeah, so this is pretty clean. You could give a try at raising gyro cut. Try raising gyro cut hertz to 100 and see if you like how it flies or if you see signs of noise. Signs of noise means kind of random. I call it twitching. It's not really vibration or oscillation because vibration or oscillation will sort of be bouncing around a central point, whereas the twitches caused by noise don't always, you may twitch one way, then twitch another way. You may pitch up and then yaw right, and then roll left a tiny bit and then pitch down, so almost as if the person holding the camera had too much coffee and their hands are a little jittery. So that's what I would look for if you decide to bump up gyro cut hertz. Just based on what I've been seeing in all the traces I've been looking at, seems like a relatively clean build with not a huge amount of vibration. Um, if this is LPF equals 188 and gyro cut equals 60, you could try bumping it up. It'll improve your latency a little bit and may improve the copter's ability to remain sort of stable and not oscillate or bobble in extreme situations, like when you're descending through prop wash and so forth. Um, so give it a try and see if you like the results. Um, one of the other things I was looking at was, yes, one of the other things I was looking at was, where was it? There we go. It was right here. Was it? You were doing a roll. I thought I marked the timestamp, but now it seems like I didn't. You're just blipping here. Oh, I see. It was in this one. Sorry. There we go. Um, I looked at your roll axis here when you do a 360 roll, full deflection. And one of the things I want to point out is let's take a look at your P term here. In fact, let's just look at your P term and your gyro. Uh, what we normally would see during a roll, and this is also true during a flip as well, is we would see the P term push hard to begin the roll. So here the P term goes strong negative. And then as the copter begins to move, the P term then reverses sign and attempts to slow the move down. So it pushes really hard. And this is probably because of the way we have our rates dialed up. We have our P terms dialed up. We want a really responsive copter. So it pushes really hard into the move. The copter begins to move, and then the P term pushes the opposite direction to sort of slow down the move to where it needs to be. Now, what I'd really like to see, ideally, is a good strong push into the move, reverse sign a push out of the move, and at that point the P term hopefully will have achieved the correct angular rate, and the P term then should sort of stay down near the axis more or less until we get to the end of the move when we push out, and then there's usually one or two oscillations at the end as the stick recenters. And so we could ask ourselves, how long does it take from the beginning of the move to the point where the P term sort of finds its where it needs to be and stays near the axis? And we can see that I think this is about the point where the P term stays near the axis. So you're basically halfway through your roll before the P term settles in and kind of finds where it needs to be. It pushes hard into the move, out of the move. Oh, we got some. Oh, speed up, slow down. So I wonder whether this is a sign of excess P, but also it could be a sign of not enough P. And I'll tell you my thoughts on that. If you have excess P, then it's going to push really hard going into the move, and then there's going to be some oscillations as it tries to sort of settle itself in. But then at the same time, if you didn't have enough P, it would give a sort of a slower push to get the move going and then not have enough oomph to slow the move down again when it needed to. And I'm not sure which of those two is more likely just looking at this trace. So I suppose I haven't given you any helpful advice at all. But what I would like to see is a good push into the move, a good push to slow the move down and achieve the right speed, and then sort of more or less staying near the axis until the end. If you could achieve that, I think that's going to be better. The other thing I saw was so right there was a little bit of oscillation, and this is not the best example in the whole video, but this is just the one I picked out when I was getting ready to record. I'll play it again. Right there. So what you're doing there is basically the worst case scenario for the PID controller. You're throttling up, you're going through your own prop wash because you've sort of spun around 180 degrees. You're spinning, you're yawing, you're pitching all at the same time. And it's no surprise that that oscillation comes out. Some pilots like to keep their P gains a little higher and accept those little oscillations. For myself, I prefer to reduce P a little bit and try and tune those out because I like more of a sort of a perfectly smooth flight if I can get it. So that combined with what we're seeing here in your trace makes me wonder if your roll P at the very least could be reduced a little bit. Oh, by the way, I couldn't get your video to sync up with your log. So ignore the video here. Just look at the logs. That doesn't match what's going on underneath there. We could certainly dig through here and look for other examples of oscillations. It's a little hard to judge because there's always some oscillation on the roll axis because on mini quads, the shape of the frame means that the roll axis is a little bit less sort of naturally damped than the pitch axis. So here again, we've got another move. What do you do here? I don't even know what happened there. A little bit of a, you enter a turn, a right turn. You're turning right now. You're turning right slowly. You're continuing to turn right, and then it ends. Yeah, so let's just look at RC command. Let's just add RC command to this graph real quick so we can see what your stick was doing. Yeah, so the yellow line is now your stick. And we've got another oscillation here at the end of the move. The other thing I saw, yeah, I wonder whether a little bit less P gain on roll might be desirable. That's a big long stretch with no data. Did maybe you turned off logging? Yeah, I think that must be it. Anyway, those are my thoughts. I hope they're helpful, and happy flying.